Hello, hello. So in this video, I'm going to solve two important problems. Uh, they're kind of good problems. To if you know the concept very well, you can solve them pretty easily. But if you don't know, these problems help you to understand the concept really well. So this is a limits problem, and I've taken a derivatives problem also. Okay, so let's start with this problem. So f of x is a real valued function such that f of x minus f of y with modulus function is less than or equal to x minus y whole square, and f of 0 value is given as 0. Then we need to find the value of f of 27. So I wrote down this thing again. So we need to know one form of limits that, no, sorry, we need to know this form of derivative that we can write f dash of x as limit h tending to 0 f of x minus f of h. No, sorry, not like that. If this limit, if x is tending to h, okay, and right at the bottom, this is x minus h. So this is a standard form of derivative we are going to use in this problem. So okay. So what do we have? In this form, we have f of x minus f of h. Instead of h, we are using y right here. So we need to create this thing and limits thing right here. So let me do that. So what can I do here is write this thing f of y is less than or equal to, I can write this two times, x minus y into x minus y. And if we do an operation on both sides, if we divide x minus y on both sides, let's divide x minus y on both sides in this equation. So when this x minus y cancels out, and I'm left with this thing, f of x minus f of y over x minus y. Okay, this is less than or equal to x minus y. So if we see this form again, we have f of x minus f of y and x minus y. So we need to put limit which is in which x is tending to y. So we can do the operation, we can put the limits on both sides. So I am putting limits on both sides, x tending to y, f of x minus f of y over x minus y, and this will become limit x tending to y of x minus y function. So by the definition of derivative, this thing on the left part becomes f prime of x, or we can say f dash of x. This is okay, I forgot to put modulus. This is right here, and this is less than or equal to, if I put x tending to y here, so this becomes x minus, sorry, this limits become y minus y, which tends to 0. Or I can say that there is several methods for this thing. Let me tell you both methods. In one method, I can say if I say x minus y is tending to h, let's say a random number which is h. So this becomes limits. If I take this on, I can take y on the left side. So this becomes x minus y. This x minus y becomes tends to h, and then h tends to 0, and x minus y becomes h. So this overall limit tends to 0, or I can simply say that if x tending to y, and if I put y in this equation, so y minus 5 tends to 0. So this upper method is if you talk about in limits terminology. Okay, so yeah, we can say like this, or you can simply do this calculation. So this on the right, the thing on the right side tends to 0, and I get f dash of x is less than or equal to 0 modulus. Okay, I get this. So this means the magnitude of this, the derivative of the function is less than or less than 0, or it can be equal to 0. So we can conclude one thing with this. If f dash of x is equal to 0, then so what is the derivative of a okay, what comes 0 when we derivative a thing? If a function is a constant function, let's say function is k, so the derivative of this function will be 0. The derivative of constant function is 0. So if this becomes 0 in a case, so we can say that f of x is equal to, okay, f of x is a constant function. Okay, so let's say f of x is k, constant function k. And one more thing is given in this question, that f of 0 is 0. So if I substitute x with x is equal to 0 in this equation, I get f of 0 is equal to k, and I get k as 0. So f of x is equal to 0 is the function for this problem. So we got our function right here, f of x is equal to 0. So we can calculate now f of 27, which will be 0, as this function is a constant function. So this is the solution for this problem. I hope you understand that. If you know this thing, then the problem will be pretty easy. You can solve it pretty easily. So let's move on to the next problem. If p of x is a polynomial of degree 4 such that p of 1 is equal to p of 2 and p of 2 is equal to p of 3, and this equals to p dash of 4, okay, derivative of p when x is equal to 4, okay, x, and this value is equal to 0. If real number is x is not equal to 1, 2 and 3 such that p of x is equal to 0, okay, x is not equal to 1, comma 2, comma 3 such that p of x is equal to 0, can be expressed as x is equal to t over q. Then okay, when p of x becomes 0, then that value at that x value can be expressed as this thing right here. Then we need to find p plus q. Okay, we are not considering 1 and 2 and 3 for this x value. This is a separate x value, and we need to find that x value, and this condition is given. It will be in form of p over q, so it is not an integer, we can say that. And they are also given that x should be not equal to 1 or 2 or 3 for this particular expression. So let's solve this problem. So let's deal with this expression. P of 1 is equal to p of 2 is equal to p of 3 is equal to 0, and this is equal to this. So let's see for this thing right now. We can deal with this later. Okay. So when do when do p of 1 is equal to 0? when we put x value is equal to 1, so this is a root for this equation. Okay, so that means if I come to express this equation p of x, I can express as x minus alpha, x minus beta, x minus gamma, and x minus delta. So this equation right here, we can write the 4-degree equation like this to solve problems like these problems. Okay, so we can see that uh, by this equation, if I subtract 1 on both sides, I get x minus 1 is equal to 0. So if I put x minus 1 is equal to 0, then p of x becomes 0. So it is a root of this equation. X is equal to 1 is the root of this equation, and x is equal to 2, and 3 also is the root of this equation. So I can write the following equation as x minus 1. Okay, sorry. X minus 2 and x minus 3. And this becomes x minus delta. And one more thing I need to add is a right here. A is a constant, and in the question they did not mention that the degree of the highest, sorry, the highest degree of x coefficient is unity. Okay, it is not mentioned, so we have to consider a constant here also. Okay, let's say if I get equation like this, x power 4 plus 2x cube and so on, blah blah blah. Here you can see that the degree is 1, and I can write x minus alpha and stuff like that with degree. I do not need to worry about any constant right here. And if the equation is like this, x minus 1, x minus 2, then I need to worry about this. So we do not know about the coefficient of the highest power. So I'm writing only a. Okay, general term a. It's okay. So it will do the work for us. Okay. So we now we wrote the equation. We just move forward in this problem. So let's deal with this right now. P dash of 4. So before substituting 4, I have to find the derivative of this full expression right here. So we have to use product rule right here for this 4 terms. If I use product rule for 2 terms, if I find derivative for this thing right here, so by using product rule, this becomes x times y dash plus y times x dash. If there are 3 terms, x times y times z, then it will be x times y times z dash plus x dash times y times z, and at last I get x dash times, sorry, not x dash, I get x times y dash times z. So if you notice the pattern, we are adding, and we are only finding derivative of one, and then second, and then third thing. So for 4 variables also we need to do that like that way. Okay, so constant, we can put constants aside while differentiating things. So I can do x minus 1 dash into x minus 2 and x minus 3 and into x minus delta plus now x minus 1, and now this is x minus 2 dash. Okay, so you know the pattern. So this becomes x minus 3 and x minus delta. Okay, Now x minus 1 into x minus 2 into x minus 3 prime into x minus delta plus x minus 1, x minus 2, x minus 3, and x minus delta prime. So this is the derivative for this problem. Okay, so derivative, let's find derivative for x minus 1. So derivative for x minus 1 is x derivative minus 1 derivative. X derivative is 1, 1 derivative, 1 is a constant, so it is 1. Yx derivative is 1 using x power n rule. So x power n derivative will be n times x power n minus 1. So in this case n is 1, so this is 1 times x power 1 minus 1, which is 1 times x power 0. So this eventually becomes 1. So with this expression, this thing right here, this thing right here, this thing right here, and this thing right here becomes 1. So let me write the simplified version for this. It is a times x minus 2 times x minus 3 times x minus delta plus, you know the deal how we write this simplified. Okay, so we found p dash of x. Let's put x is equal to 4 in this equation. So we know the value of p dash of 4. It is 0 on the left side, and we need to put 4 instead of x on the right side in this equation. So this becomes 4 minus 2 times 4 minus 3 times 4 minus delta plus 4 minus 1, 4 minus 3, 4 minus delta. Okay, 4 minus 1, 4 minus 3, 4 minus delta plus 4 minus 1, 4 minus 2, 4 minus delta. 4 minus 1, 4 minus 2, 4 minus delta. Okay. 4 minus 1, 4 minus 2, 4 minus 3. Okay. 4 minus 1, 4 minus 2, 4 minus 3. Let's simplify this. This becomes 2 times 1 times 4 minus delta plus 3 times 1 times 4 minus delta plus 2 times, no, sorry, 3 times 2 times 4 minus delta plus this is 3 times 2 times. Okay, so if I take common 4 minus delta in this 3 terms, this is 2 plus 3 plus 3 times 2 is 6 plus this 6 separately. So this is 2 plus 3, 5, and 6. This is 11. 11 times 4 minus delta plus 6. And let's multiply this thing. 11 times 4 is 44 minus 11 delta plus 6. And we know that this is going to be 0. Okay, so 44 and 60 is, sorry, 44 and 6 is 50. This becomes 50 minus 11 delta is equal to 0. Okay, if I add or if I send this equation on this term on the right side, or if I add 11 plus 11 delta on both sides. So this on the left side cancels, and I get 50 is equal to 11 times delta. So let's divide by 11 on both sides. Then I get 50 over x. Oh, sorry, 50 over 11. Delta as 50 over 11. So, okay, one more thing I forgot is the a on this thing. A. So as you know that a is a constant. Okay, let's just say I'm multiplying with a. Okay, a. A is a constant. If I divide a on both sides, I get this equation. Okay, so we don't need to worry about that. If I miss this, if I missed that, sorry for that. Okay, yeah. Now all things are clear. So then I get my equation like this: p of x is equal to a times x minus 1 into x minus 2 into x minus 3 times x minus 50 over 11. So we got 4x values. X is equal to 1, 2, 3. And the fourth x value is in the form of p over q. Yeah, it is in the form of p over q, which is x is equal to 50 over 11, which is, they told us that this is p over q, and we found that. So we need to find the value of p plus q. So the value of p plus q will be 66 for this problem. So this is a solution, and this is the correct answer for this problem. And this is a solution for this problem. I hope you understand that. So yeah, these are the two problems. This also include limits. A kind of limit problem. This is the form of limit for the derivatives. Okay. So this two are derivative problems, good problems. So I hope you enjoy the video, and leave a like and comment. And if you want to, you can subscribe. Thank you for watching.